Shabbat Shalom to the home team. Once again, we're here on YouTube. Alright? Extension of Tokef Benak. You heard me? You want the real drop? You want it first? Come to Drop Nation. 432 to Drop Radio. You heard me? You'll get it exclusive from your boy yourself. Alright? Let's see what's popping home. You heard me?
Jack War like Game of Thrones, but whose bloodline, you know what I'm saying, is truly noble. Who's the real Regal? You know what I mean? Everybody can't be Regal.
Nah.
Regal is appointed by the creator of the earth. You dig? Everybody can't self-title themselves and their tribes as Regal Nagas. You know what I mean? So just keep on flowing, man. We're gonna allow it to, just connect all night long. You know what I mean? We're just gonna allow it to connect. We're gonna drop some great features and let those connect with what you're digging on already, man. This is the Press the Hour, man. Keep on tuning in, keep on flowing. If you missed this drop or you want to hear it again, I'm about to drop it right away on the website, man, so you can get it and just flow with it. And definitely Ahau to Ahchwa for this great source, Press the John, the legend, and its sources, man, compiled and translated by Keegan Brewer, digging on the Crusade text in translation 27. Ahau, keep surfing away, Drop Nation.
Quam, you heard me? Drop Nation, Quam. Alright, we just felt belly flopping, you heard me? Belly flopping here at 432 to drop before we get started here, you heard me? Get them Tide Battle poetry poems, you heard me?
We on the warpath.
Always. Get that Tokef Benak, you heard me? Straight up. Get that facts in your life, you know what I mean? No play.
Price is going up.
Already, drop.
Press the Hour. Season 2. Ahau. This is episode 10, man. We flowing again. I mean, last season we did 45 episodes of the Press the Hour. We scaling back a little bit, man, but we up there, man. I mean, we up there. I mean, I don't know. Family, I don't know of anyone else, man, outside of Drop Nation who's put as much hours and energy into investigating our priest kings, which are also called presters, presbyter, prester johns. It's not one person. It's not one man. I'm talking Joshua, man. I'm talking Kitzikotu, man. I'm talking Moshe, man.
Priest
kings. You feel me? I'm talking Jeremiah, you dig?
Man, I feel you.
I'm talking Isaiah, man. I'm talking about the energy, man, that comes from Hawa when Hawa is bringing a shepherd to guide the people, to speak to the people, messengers.
True that.
I mean, these are priestly Khans. We're talking about the Khan dynasty. And specifically, we're talking King David.
Straight
up. You know
up.
that.
No play.
And I'm back in Prester John, the legend, and his sources. Love to Ahchwa, man. I just love this book, man, because it just brings you right into reality. No guesswork. No guessing games. Got to give some more Ahau to our brother and our sister, man, rocking the light hour, man. I mean, man, they breaking down Kateo, China, all this in America. Great document. Please get in that classroom every Monday night, 8 o'clock Pacific, 9 o'clock or 10 o'clock Central. And it's just a great serve because it serves, I mean, we got the maps, man. We got the maps of Kateo and Zapangu or Kapangu and all this. And if you ain't talking about that, what are you talking about?
What are you talking about?
This is China, man.
Let go.
This is Japan, man.
Let
you
go.
dig?
Hi. Ahau, brother, drop. Let's go and start our investigation over here. Alright. Let's pop off.
Crystallography.
What we've been discovering. What we've been on the warpath on. What have we been discovering? True mem. Right? Primary mem sits under us. Alright? We gotta understand the crystallography. Okay, this is a branch of science concerned with the structure and properties, of crystals. Let's get it. And what you need to understand is that when we talk crystallography. You hear me? All we're talking is primary rock. All we're talking is mineralogy, geology. All we're talking is rock. Okay? Crystallography is an experimental science of determining the arrangement of atoms in crystalline solids. What are crystalline solids? Crystalline solids are from magma, lava. We're talking crystals. We're talking gems. Alright? See, crystal structure. The word crystallography is derived from the Greek words krystallon, krystallon, okay? In its meaning extending to all solids with some degree of transparency, okay? Alright, let's get it. 1828. Alright, Webster's Dictionary. Crystal. Alright? In chemistry and mineralogy, okay? An inorganic body which by the operation of affinity has assumed the form of a regular solid. Okay, we're talking about what? Gemstones, okay? Crystals, you see it, okay? Terminated by a certain number of plane and smooth surfaces. A factious body cast in glass house called crystal glass. A species of glass, more perfect in its composition, okay? And manufactured than common glass. The best kind of Venice crystal is called also factious crystal or paste. A substance of any kind, the form of a crystal, okay? Rock crystal or mountain crystal, a general name for all transparent crystals of quartz, particularly limped or colorless quartz. Iceland crystals, a variety of calcareous spar and crystallized carbonate of lime brought from Iceland. It occurs in laminated masses, easily deceivable into rhombus, and remarkable for its double refraction. All right, consisting of crystal or like crystal clear, transparent. All right, we know what crystals are. Okay, the glasses, the rocks, right? Okay, and we understand that crystallography, okay, is the arrangement of atoms in crystals. Okay, so now let's get this drop. Mineralogy, you see it. All right, you see it. Mineralogy is the study of minerals, their crystalline and chemical structure, okay, and their property, such as melting points. A mineralogist is a person who studies minerals, which technically include all naturally occurring solid substances. All right. See, these people play games. You heard me? They play games. They got all time to play games. All right. Specific studies within mineralogy include the processes of mineral origin. What's the origin of mineralogy? Okay, what's the origin of crystals, of crystal structure? Okay, we're talking magma. We're talking lava. Okay, we're talking igneous rock. Okay, and formation classification of minerals. Check it out. History. Early writing on mineralogy, especially on gemstones, my naga, okay, comes from ancient Babylon. Alright? Where it comes from? Hijack 101, Luciferian. Alright? What we talking about? Babylon. What comes from there? Gemstones. What are gemstones? A piece of mineral crystal. Simply what? Mineralogy. Okay? Mineralogy. Okay? What is? Early writing on mineralogy, especially on gemstones, come from ancient Babylon. Hijack 101. Alright? Straight up. Alright, so let's get this. Hijack 101, right? What's primary? Okay? First, in order of time, original, okay? That's the hijack as the Church of Christ in its primary institute, okay? This correlates with this. Primary qualities of bodies are such as are original and inspirable, okay? Key word, inspirable from them. What is inspirable? This is why this is popped off, okay? Understand what we're talking about. We're talking about the first in order of time, original, okay? First in dignity or importance, chief, principal, okay? Radical, original, as the primary sense of a word, okay? We're talking primary qualities of bodies are such as are original and inspirable by them. What's inspirable by them? What is inspirable? What? Gemstones are inspirable, okay? Babylon. Come from where? Babylon. What are gemstones? Crystals, Cristos, Cristos, Jesucristo. You feeling me? Cristos. So, what's inspirable, my naga? The story of Jesus. You heard me? The story of Jesus, my naga. Because what? Primary qualities of bodies are such that are original, inspirable from them. Primary, first in order of time, my naga. Straight up. Okay? Now, let's cover it. Let's get it. I'm on the warpath over here. Okay? Geology is an earth science concerned with the solid earth. What are we talking about? We're talking igneous rock. We're talking primary rock. We're talking mineralogy. We're talking crystallology. Okay? The rocks of which it is composed and processed. Okay? By which they change over time. Geology can also include the study of the solid features of any terrestrial plane, natural satellite, that's the hijack, Mars or moon, or the moon, okay? Modern geology significantly overlaps all the earth sciences. They, what? Significantly overlap all earth sciences. Why? Including hydrology. What's hydrology, my naga? We've been studying it, man. The movement of water is the scientific study of the movement, distribution, and management of water on Ahau. Alright? They combine all this together. Why? Anyway, let's get to it. Okay? Because geology includes the study of solid features of any terrestrial planet, terrestrial thing, my naga. What is terrestrial? Okay? I just gave you an example. Okay? A natural satellite, the moon. Alright? What's terrestrial? A meteor thrown from the clouds. What are we talking? We're talking rock. We're talking primary. We're talking first in order. What is first in order? What is the mem? Superior mem. Who is superior mem? The Presta. A meteor thrown from the clouds with such violence that a collision is set on fire. Nonetheless, ain't no collision about it. Okay? When a dragon ascends and it descends, it's naturally on fire. Alright? Understand and overstand, man. We're on a warpath over here, man. We're on a warpath because we understand and overstand that mineralogy, okay, is the study of what? Crystals. And what? Early writings, especially on gemstones, come from where? Babylon, my naga. Roman, right? Hijack, Luciferian, 101. What are we talking about, man? We're talking about gemstones, okay? We've been had the drop on gemstones. Our Khan priest been had the drops on gemstones. We wore a plate, a vest with different mineralogy on it, different crystallography on it, okay? Whatever you want to call it, igneous rock, all right? But what was it though? We gave what? We gave order, okay? Order, first in order of time. Who? Presto, the function. Primary mem, my naga. Understand and overstand that everything is a duplication. Everything reverts back to the function, all right? So we overstand that. All right. Igneous, right? Consisting of fire, as igneous particles emitted from burning, okay? Resembling fire as igneous appearance, all right? Straight up. What we talking about? Igneous rock, okay? Igneous rock is primary rock, okay? Straight up. Mineral rock, okay? Straight up. Understand that when Hawa created a naga, you heard, when he created a dam, okay, there were primary things for a primary naga, alright? There were primary mem, okay? It was primary light. It was primary of abundance of things, okay? We're talking about the first in order, alright? The first order, primary water, primary rock, primary land, primary trees. There were primary things for a primary naga. You understand me? Alright? So understand and overstand that everything goes back to this. The presto, the function. Alright? Alright, let's get perspective. Alright? Let's get perspective. Let's understand what mineralogy is. Let's look at mineralogy. What is mineralogy? Stones, crystals. You see it. Crystals. Okay? So this is what we're looking for. Okay? You don't have to be looking for exactly a whole crystal. Okay? It can be broke down. Okay? That's why you need to test the soil. That's why soil samples must be done. Okay? See this right here? When you do this, this is the study of atoms. Okay? This is the symmetry. Okay? So this is when you refer to crystallology. Okay? Crystallology. Okay? Mineralogy. Rock. Okay? So we got perspective. Okay? We're getting perspective. Okay? Now, let's get a perspective on crystallology. Okay? Images for crystallology. Alright. What do you see? You see the study of structure. Okay? Because that's what crystallology is. It's the study of structure for certain rock. Okay? For certain crystals. Not all crystals have the same property. Not all crystals break down the same. Okay? So, you gotta understand and overstand that crystallography is basically the study of the atoms. Okay? The symmetry. Okay? Check it. Crystallography is the science that examines the arrangements of atoms in solids. Okay? The word crystallography derives from the Greek words krystallon. That's what we got earlier, right? Okay? We already know. We already know. We already know. Inspirable accounts, you dig? Straight up. Inspirable accounts. Okay, so inspirable that they create what? This. An illusion. You heard me? Nothing that's primary. First in dignity. First in order. Okay? We all already know. Presto. Alright? So, understanding what we're looking for with mineralogy. Okay? understanding what crystallography is and what we view it as, okay? It's a basic structure, the breakdown, okay? So, all right, let's get the visual, let's get the perspective on primary rock, all right? Look at your primary rock, okay? Look at it. This is what we're looking for. This is primary rock, all right? Primary rock is igneous rock, all right? Primary rock, we're talking about rock formed from lava, okay? Igneous rocks, oldest types of rocks, also called what? Primary rocks. Look at it. That's what we're looking for. Okay, so we're looking for the breakdown of primary rock. Okay, being that primary rock, igneous rock, was first in order. Okay, we're looking for the mineralogy. Okay, included in that. Okay, we're also studying the crystallography, okay, the structure, the breakdown of certain what? Elements, certain crystals, okay? So we understand that for the most part, all this correlates, okay, to being primary igneous rock, okay? Rock from magma, okay? Rock from lava, what have you, crystals, okay? Crystals. I don't have to show you a visual on crystals, y'all know, okay? But these people play so many games, okay, that you gotta understand the terminology, all right? Primary rock, okay? Primary rock, okay? So being that we correlated primary rock, igneous rock, okay, we've got a perspective on mineralogy, crystallography, okay, we got one more thing to look for, all right, we probably got a couple more things, we don't really know yet, but we're on the warpath, okay. The next thing we're going to be looking for dikes, okay, cliffs, okay, see, this is a cliff, dike, okay. This is rock. He said we're looking for rock that belong there. We're not looking for rock that somebody just threw there, the pebble. All right? We're looking for rock, my knots. Rock that belong there. Okay? Dikes. Okay? It's a bunch of cliffs and dikes by the water. We want land. Okay, so let's do this. Perspective, all right? Let's get it. Looking for dikes. Look. You coming in at a what? That's not a 90. It's probably about like a 65, 50 degree angle or something like that. But irrelevant. It don't matter. All right. A real good, strong dike will probably come in at a 90. Okay. But this is what we're looking for. This is a dike. Look. Water used to come here. Water used to run through here. Okay. We're not actually looking for a float, okay? The dike is just to be a carrier, all right? The dike is just a carrier. It's a highway for the water, all right? Or whatnot. If it looks like this, or it could just look like a cliff, okay? We're actually looking for plates, okay, that move, platonic plates, okay, that push underground under a mine, you feel me, and they cause a upshift in the rock on the earth, okay, and that's how you have your dike, that's how you have your cliff happening, all right. So we gotta get perspective, man. Gotta get perspective. Right here, my knock. This is dikes, okay. Cliffs, okay. This is, look at this, rock all over there, rock everywhere, okay. Might be a good spot to test, depending on what that says. And you don't want to hit up here for what? Even if you test up here and you got good reading, you don't want to test up here. You gotta go through all that. You want to test down here. You want to test down here, okay? Right by this. And again, you know, look. Dikes, okay? And again, you know, I'm just going based off my discoveries, what I found, okay? I'm just going based off my discoveries of what we've accumulated, all the information we've gathered, all right? Dikes, you see it, okay? But you're looking for rock too. You want to look for rock too. Notice when I put cliff, there's water around. Look at that. It's a dike. It's a mountain, okay? But it's been pushed up. It's a tree. Alright, this is primary. Test that soil around there, okay? Yeah, I notice when I type in cliffs, it's like it's by water already. It's like it's a levee. It's rock all over there. Mineralogy all over there. Alright, let's get it. Where we at? With this Stephen Reese.
Have you ever done any analysis of the type of structures, Steve, where these springs are located? As far
Oh,
as
naturally, on that
composition?
basis, I'm locating my wells.
Yeah.
If I know the crystallography and the mineralogy, then I know that I can depend on that good water and drill it.
And the crystallography and mineralogy would indicate to you which areas are contiguous with that go into the magma, basically.
Naturally, they had to have the direct source and continuity there.
How does that actually relate, though, as far as, say, if you have a dike?
Yeah.
You know, maybe you're on a dike coming out. Are springs usually connected in contiguous?
Well, generally always on a contact zone.
Okay, on a contact
whether
zone.
the dike surfaced or not.
Okay.
But it has to be a surface zone. Now the point is, what people ignore, I can go over over 1,000 acres of land, say a whole section, whole mile, on these ranges, and I find variations from 5 to 10 different types over that 1 mile, mineralogically
okay.
and petrographically.
Right, right.
The ordinary person who doesn't even recognize
Now, are you
it.
talking about surface rock, or are you talking about actual dike structures that connect?
Rock that I know belong there,
Okay.
dike strike.
So you're looking for something that's contiguous with
not a
the,
float.
with the dike. Right, not a, no.
And there I can determine directly whether I have contact to the magma.
Okay, that's the, okay, so you...
So, overstand, right? What he's telling you, that if he knows the crystallography and the mineralogy, okay, that he can depend on that well. He can depend on that well, my naga, for good, superior mem, okay? Depending on the contents of that, okay? But he's not telling you to just dig anywhere. You have to dig where, if there is a dike, you want to dig where there's rock, okay? Remember, primary rock. Remember, rock absorbs water.
The water has to come from the magma.
Right, but because of the mineralogy and petrology of the dike, then,
Yeah.
you can say that this indeed is something that is in contact
And the
with
metals
dike.
contained therein. In analysis, what metals and minerals are involved,
Primarily the sulfide group, like...
then I
lead
know
sulfide.
that I'm right. And I can dare to drill a well and expect some real good water.
So you're saying then you might have a situation where you've got one dike here, 100 feet away, another dike. The mineralogy would be such different enough
Oh,
that in
completely.
one case there would be water connected with it, in another no water.
Not 100 feet away, right on the other side of the dike.
Do you generally see dikes, you know, in general, would you see, like, if you got a dike formation here, for example, connected with water, would there generally be dikes very close in proximity
Yes,
to other
various
dikes?
other types.
But not necessarily dikes that are connected with water forming.
No,
Would you call them basic?
mostly not.
Could you say, like, there would be water forming dikes and non-water forming dikes? Would that be an accurate way to describe it, or not?
I would say water flowing, containing.
Okay.
The dike itself does.
Check it out. Okay. This is the dike. All right. This little hill, this little patch right here. This is the dike. All right. Remember that the dike is just a highway. All right. Where this water's sitting. Okay. Understand that what makes this is usually rock. Okay, you might have a little higher land somewhere, yeah, no doubt. Majority of the time, it's rock.
Doesn't have the water.
Right, but did at one time, or
They
came
have
from
the carriers.
carriers. In other words, okay.
But the mineralization produced the water as the mineralization intruded. Say a pound of copper, a pound of zinc, or whatever it is, might have had millions of gallons of water depositing it. Millions. Read that book from Salzman. We had figured out how many gallons water it takes for 1 pound of borax.
I read that. It's incredible.
See?
Yeah.
Borax is an unknown element prior to 50 million years ago. And the biggest deposit apparently has been Creamer, Colorado.
California.
There is an old borax mine in China.
Naga just found borax. You understand? Y'all know borax got plenty of health reasons. Alright? Plenty of health remedies. Borax. Alright? Get the drop, do the research. Alright? Can't cover everything, but I can steer you the right way. You know what I mean? So let's go, let's get it.
Amounting to much. But that's tertiary. That's the latest mineralization on this planet.
So, if you have a dike then that you feel is a water former because of the rock analysis, the reason that water is still coming today then is that it is still, you feel, in direct contact with the magma.
With the magma.
But that would generally be somewhere 1,000 to 2,000 feet down.
20, 50.
But the connection or the contact, what I'm trying to say is, where would you access? How do you know if you've got a dike here with the proper mineralization?
By the debris. What kind of debris is showing on the dike?
Okay. But
What's the mineralogy of it?
I understand that. But once you have that,
Yeah.
how do you decide then?
Overstand what he said. The debris is the mineralogy of it. Okay? I don't know what's up with dude. Dude keep asking the same question. I don't know what he getting at. But nonetheless, we keep getting some info out of his ass. So, let's go. Let's get it.
And what is the basic principle that you're going on as to how to get water from that dike or near it?
What is the other side of the dike analyzing? Maybe 10 feet away and I'm out of it. I gotta follow the contact zone, whatever the incline or dip is.
And then you would drill the well, for example.
So you follow the incline, okay? Follow the incline, regardless if it's cliff, what have you. You follow the incline, all right? And you never take the sample at the top. You feel me? You always go to the bottom where the incline at.
You've got a dike coming at a 90-degree
Oh, and
strike
I'm over here drilling. I'm not there.
Okay. So
If the dike shows here, don't mean a damn thing. I gotta get this down here.
Because here is where your fracture zones are.
Right.
That dike is because there was a fracture of the granite plate.
No other way. And then
And
a
the
displacement.
fractures are all in the elbow, not in the tip.
And then it's a displacement
Yes,
fracture.
and those fractures are
Straight
allowing that steam, which is creating the water coming up from the magma, to be there at all.
That's the passageway.
That's
The steam is way below. The steam is 5
miles
miles,
below.
10 miles down.
But the steam is the pressure that keeps the water up in those fractures.
Right, right.
The bottom pressure is continuous. This is a continuous process. It doesn't have any end to it, does it?
Now, science is slowly admitting it. There is 28 universities now
Science.
petitioning the government to put up 8 million immediately to start drilling 15,000-foot holes to capture the steam. The steam means not a damn thing.
But they're saying and admitting that there's steam there as primary steam, but they're
Right.
denying that's primary water. And if I'm not
Naturally.
incorrect,
So understand, if you got primary mem, you got primary steam, you got whatever you can get out of the water, that's primary. If your plant's observing primary mem, then you got primary vegetables. You understand me? Look, man. This ain't no play, dog. This for real. This for real, fam. Look. If your plants and your trees make oxygen and they getting primary mem, then you're getting primary oxygen. As simple as that. It's a chain reaction. A chain reaction, straight up. Let's get it.
steam is water in another form, is it not?
Naturally, they've
And you've
denied
been
that.
saying this for 40 years?
Since I came out of
Stephen?
school.
You've been now in connection with your work in the mining field.
Yeah.
You found virtually invariably that when you got to a certain depth in these deep mines,
That
that
is
you
what?
would hit this water that you're describing,
Right.
and it would flood the mine out.
That
That's one case when you didn't want that beautiful potable
That
water
is correct.
because it was destroying the whole operation.
But I learned what to look for, not to get caught in it.
Yes, and you learned that that water was perfectly usable because I understand at one time you carried some of it for the camp cook and he was astounded how good the water was.
That is correct. But I had to, on mining, watch out not to get into one of those streaks.
And this is how you found to watch the evidence
minerals.
in the minerals.
And the metals in the content.
And when you got and saw these things, you knew that water was close and you got to be careful.
Under given volcanic debris. See? Which then is, of course, crystallizing, but not usually very, very crystal, very solid. Usually a rotten stuff. Never really crystallized properly.
Yes, fractured, broken, poor,
Yeah,
weathered,
weathered.
material.
You would see this on your cut, on the mine cut.
Oh yes, I can see it right by getting it. Then I know I have a deep-seated fracture.
And on the basis of that, you could frequently sort of go in another direction or stay away from the major water coming up?
Well, once you're down in an area of 4,000, 5,000 feet,
You sort of
the water pressure is so goddamn high it comes through the moment you get near it.
Steve, have you ever actually seen water just flowing through these fissures?
Why, sure.
I mean, actually flowing through?
Oh, sure. Certainly.
You may have this water in there in these fissures up to pressures of 600-700 pounds, 1,000 pounds per square
Yes,
inch,
yes, yes.
with the steam pressure pushing it.
No, there's no more steam. That's already too far down
But
below.
the pressure of the steam is still there.
The head is still there, plus the weight of the formation. The weight of the formation is hitting incompressible material.
So
Water.
This is,
So the water being half as heavy as the material that's holding it,
And totally incompressible.
and it's got to come through.
It must be forced through any way that it can be
No
found
matter,
out
just-
of the fissures.
The least little crevices and through it goes, and then once it has a runway, it'll dissolve and dissolve and dissolve and
This
make a
is-
larger.
This is the principle of the hydraulic system, isn't it?
Naturally, there's no question about it. There's nobody disputing this.
The instant pressure is put on one end of a hydraulic system, it's instantly at the other end because of the
Absolutely.
incompressibility of the water fluid.
Absolutely, I've seen that water come in so fast it isn't funny.
So when you free that one end, the total pressure that's there is going to flood the area that you
Flood
free.
the whole damn area. I've been drilling into those damn things and pulled the drill rig out on the mine, and the boys pull the rig out and get hit with a heavy spring of water. Right under a high pressure hose, hits them right in the face. Little drill hole.
And continues to come out of there
Never stops.
until the mine is flooded and you can't see it
That's
anymore.
right. Till it found its pressure.
Found its pressure level.
It
When
make-
the weight of the water and the pressure are equal, it stays there.
Now the last big discovery was in Africa in one of the big gold mines. I happen to own stock in. They went from 5,300 feet level to 8,300. Rolled the shaft, went down. Hit the water, out. 87 million gallons a day.
87 million gallons a day.
Yeah. And it came up to 5,000 feet in the mine
And stayed there.
and stayed there. That was the equal of the head behind it.
A 3,000 foot head, a 3,000 foot with pressure.
Yeah, sure.
Equal to the 3,000 foot pressure. The
Yeah,
weight of the water at 3,000 feet.
yeah, it was about 1,400 pound pressure of water.
So this water that you're finding in these deep crevices is continuously trying to seek an equilibrium
That's
with
right.
its pressure.
And if you find it fairly solid in your material, you shoot through. Watch it. You're not far from it. See? If you keep on going, you just lost her. She's bound to come in.
And there's no such a thing as an exhausting of this supply.
No, hell no.
Because it's continuously being born.
It's absolutely impossible there be no water on the planet. At the daily loss of water on this planet by each blade of grass, by every vegetation, everything alive, There'll be no water in the oceans in less than 3 million years.
So-
So it's split.
So many years ago, you forecast that the oceans, when they get down to find it and are able to test it, would have massive amounts of potable fresh water
Naturally.
in the bottoms.
I kept telling him that. That's the only source of water we could have.
And now when they go to find the Titanic at 12,800 feet, they're finding just what you said.
Right, and here, the last Scripps Howard expedition there, 12,000 feet in the Pacific, they found a 3-inch spring, flowing beautiful fresh water, and a little ways away, a spring, or whatever it is, 700 degrees steam.
Now, why is that, Steve? Why does one have fresh water and one have steam?
Different source,
Different source.
different connection, different dike.
Like you had talked about earlier, different
Right.
dikes. One dike here having a,
My 3 wells in Idaho, in Conway,
yes.
they are less than 200 feet apart, all 3 of them. And each one has different chemistry. And each one is big well, big flowing water, but not the same water. High class water, but the chemistry is different on each one of them.
So the root of this dike, these different various dikes are going down to,
Right.
they're all connected with magma, most likely.
They have to.
Like, I guess what I still don't understand is why one dike here, one a few hundred feet away, going to the same source, would one would be highly sulfide, mineralized hot water, where the
They
other
don't go to the same source. They're different.
The fissures are all different, going
Different
to different
leads.
sources.
They come in on that last extrusion.
You're
Okay,
working
so-
with the tops of the fissures.
Right.
And the fissures are at angles, so as they proceed down through these 25 miles, they're miles apart at the base.
Lord, yes, that water may come up here on one fissure and its source is over there.
Right.
Or from here on they split away like this.
They split from the top this
Right.
way. Because what you really have is a big chunk of granite that's been fractured like that as a result of volcanic action
Not
and
the
left
gra-
a lot of fissures,
Not the granite.
not the granite.
Granite is seeded volcanic rock.
Ah,
Granite is a crystallized sedimentary, mostly ocean.
ah. So it's not the granite. What is it that's fractured below then?
The basic debris, which is the what we call the plutonic rocks.
Subgranitoid material.
They're way below the granite source. They're below the basalt.
Below
Way
the
down.
basaltic rock.
Yeah. This granite here all was marine sand at one time.
It was unfortunate that we just have to go down through that hard granite to get to these fissures.
Not always.
But sometimes.
Sometimes, no. The wells we drilled here up, that Maya drill, they never hit the granite.
They never hit the granite.
Never. They didn't intend to either. There is a few granite big blocks like this laying on top, but they never were there originally.
So what type of material is it that he's going down through now?
Volcanic debris,
Volcanic
all
debris.
kind of mixture. Analysis, nothing positive. You can't classify it as this or that or the other. It's just a mishmash.
So it's basically, you might say, a volcanic sedimentary that's been there probably for millions of years. And
Over
slowly-
for millions of years.
Volcanic conglomerate.
Conglomerate. But no crystalline structure.
And basically there, for example, where Myers is now, you've intersected the fault lines that connect at a very
The
deep
contact
source.
zone,
Yeah. Okay, so-
And that's where that water is migrating on.
What I still don't understand for sure, Steve, is why if you have this massive fissuring system down there with all these branches basically coming off, where going back to the hydrothermal vents at the bottom of the ocean, why one of these is going to be such good fresh water, another's going to be mineralized.
Come in from a different source. They have a different or outlet.
Okay.
That is not the source there for the water. This one may come from way there. This one a half a mile further in. But they are all different and wind up in this outflow structure, which was created by the gases and the volcanism.
They literally converge at the top,
Right.
but they're dispersed at the bottom.
Completely.
And the reason one is a freshwater, potable, drinkable source
Yeah.
is that it depends on which rock formation it goes through,
Naturally.
as opposed to the one that's highly mineralized.
How long it's been locked up and what type of metallic structure. If it's in the water, in the rock with about 500 or 1,000 or 10,000 years, it dissolves the minerals.
So the water you're able to intersect basically is basically it's
Condensed steam originally.
right. I guess what I don't understand is why that condensed steam in some areas it's mineralized, other areas it's not. Where it's not mineralized, the minerals basically precipitate out on the way
If the steam comes through a highly mineralized fishing, then you got bad water. See?
What would determine that? Well, what kind of, say, highly mineralized fissures? I mean, like
The dissolving of the
Alright, so we're going to defer from the video for a little bit, alright? And we're coming here. This is the Primary Water Institute, alright? This was done by Stephen Reese, okay? And it's now taken over by his protege, okay? So, let's get it, man. A recent study documented the presence of vast quantities of water locked far beneath the Earth's surface. The study confirmed that there is a very large amount of water, alright, that's trapped in a real distinct layer in deep Earth, alright, deep amount, approaching the sort of mass of water that's present in all the world's ocean. Alright, let's get it. Alright, we'll come back and visit this, but Brother Drop broke this down right here. He had the actual video and broke that down, so you might want to get that perspective. But we'll take a look at it if we get some time. Let's go on a dig, man. All right, new perspective on source of the post Napa quake water. All right, as Solano County enjoys an incredible new flow of water in local creeks after the recent Napa earthquake, experts are speculating what might be the source of this bonus from nature, okay? Official report that at least 200,000 gallons of water per day are flowing from Wild Horse Creek, with many other areas reporting similar phenomena, all right? So is our mem coming back to us? Water quality tests performed by local public works official confirmed that the new water is pure managa, enough to drink, all right? This new water is being added to municipal drinking water supplies, okay? A great blessing to local residents. Although federal government geologists report that the new flow of water is likely shallow groundwater, suddenly released, okay, from opening of fractures. Other theories exist that offer great hope for a thirsty world. All right, during a recent interview with Paul Poirier, okay, this is the protege. This is the protege of Stephen Reese, okay, a respected American hydrologist. Okay, what's the hydrologist? We studied that. We covered that. Hydrology is the study of the movement of water, okay? Stated that this post-earthquake release is an excellent example. Primary, which comes from rain-fed shallow aquifers, but rather from very deep source far below. Typically, aquifers levels, primary water source are independent of rainfall, okay? They're independent of rainfall, meaning that this is not rainfall water, okay? Meaning that this water has never been contacted with any outside source other than its own mem, and appear to be virtually unlimited. Unlimited, my naga. You heard me? Although the science of primary water is not widely known, okay? It's not going to be widely known. Because why? This is $1 billion industry. At the end of the day, we, the people, going to what? The stores. To do what? To get wata. Okay, wata that they tell us that is purified and that is coming from a spring or whatnot, and that it's not toxic, that it's safe to drink. But it's exact opposite, okay? All the wata on the ma has been contaminated that sits upon her, okay? There is much evidence to support its existence. Okay, in fact, a recent study reported in Scientific American documented the presence of vast quantities of water locked far beneath Earth's surface. That study confirmed that there is very, very large amount of water that's trapped in a real distinct layer in the deep Earth, approaching the sort of mass of water that presents in all the world's oceans. All right, although primary water originates from geological processes deep within the earth. Pure says it can be tapped, and has been tapped for use at or near the surface of Earth. This is because primary water naturally pushes up through fracture zones in the Earth's crust. It naturally pushes up. Understand that water is incompressible. What I mean by that is that you cannot compress water and expect for it to compress. Water is incompressible. Water is used for pressure in the industry. It's where you get pressure from. Understand and overstand. They use water for pressure. They use water for money. It's gonna continue. All right, let me see. This is because primary water naturally pushes up. That's what I wanted to tap on. See, it naturally pushes up because it's incompressible. This land, the land that we're on, sits on top of water. So it's constantly being compressed, and any slightest gap, it could be a 3-inch hole, 1/4 inch, 1/2 inch. It's coming through there. It's constantly being compressed. So this mem that's being produced is constantly being compressed. Therefore, it shoots out. At any given chance it has. All right, so let's go. This is because primary water naturally pushes up through fracture zones, in the Earth's crust, as illustrated in the diagram above. High pressures in Earth's mantle make this upward movement of valuable resource, in some case primary water, can be found at the surface of Earth, as demonstrated by many natural springs. Primary water can also be accessed by drilling near the surface, less than 200 feet. In other cases, earthquakes, such as the recent one in Nepal, can remove blockages and open channels for primary water. Look at that. All right, earthquakes can open channels, and let loose what? Primary water. This can facilitate sudden release of this great gift from below. Pure points out that there are other indications that the newfound water in Solano County is indeed primary water. For example, there is no major reports of sinkholes or subsidence associated with the release. If this massive volume of water had been released from a shallow aquifer, an equivalent volume of water would have had to replace the volume withdrawn so rapidly, over 1,000 gallons a minute, which is over 10 times the pre-quake flow. Otherwise, massive sinkholes subsidized would have appeared. The lack of sinkholes and subsidence indicates that the source of these new waters must not be shallow aquifers, but must be primary mem in origin, all right, from much deeper prolific sources. These primary water sources, in fact, were so prolific they were able to sustain surface stability even as massive volumes of water were released in situations such as this. As depleted aquifers are replenished by primary water, variations in flow may be expected, until equilibrium is reached. So remember, we talked about this water is gonna come out until it feels the same pressure again, okay? Until its equilibrium has been met, okay? After many decades of successful primary water studies and drilling projects, Pure has proven that we can access this abundant source supplement, okay? Our current water supply, primary water, may be tapped directly or may be found coming in with secondary water fed from atmospheric sources above. As more people become aware of this little known science, perhaps the Napa earthquake will be remembered for helping us look down instead of up. The solutions to our current epic drought crisis. Alright? This is coming straight from Primary Water Institute, my Nagas. You understand? You heard me? This is the primary cycle driven by Earth's energy. Okay? This is natural. Okay? But this natural process is chambers. It's chapped. You heard me? Because all this water that sits on top of a mine, you understand me, is contaminated. Okay? These are the channels. You see these channels. You see these channels. Okay? You see these channels. See these channels from where this mem flows, and understand that the mem has to come from a lava. Okay? It has to come from lava. Understand? Okay? And these veins, they sort of open up. They open up even more so the more they go towards this bottom part. Okay, it only makes sense. Alright, we'll touch on that. Let's see what we got over here. Primary water cycle, Primary Water Institute. Let's check this out, man. See, this is primary mem. Alright, this is primary mem. Primary mem right here. Alright, Primary Water Institute is dedicated to teaching what is known about volcanic origin of water. Okay, the volcanic origin of water from deep beneath the crust of our living world. This new water arrives at the surface through cracks, okay, and fissures in rock strata, okay, due to tectonic forces far below, okay, adding to the hydraulic cycle, the movement of what? Water at the surface and in ocean basins, okay, fissures in the ocean floor, okay, cracks cause hydrothermal vents that release superheated water, okay, rich with mineral content to mix with seawater. Geysers, okay, the result of volcanic action beneath the surface under pressure, spray primary mem into the air and bubbles into the surface. Hot springs often found in mountains, okay, areas spring forth from cracks and fissures, okay, fractures caused by intense pressure built up by steam and water within the rock strata. Okay, the drought that has been afflicting most of the western states for 13 years may be mega drought, and the likelihood is high that this century could see a multi-decade dry spell like nothing else seen for 1,000 years, according to research presented at the American Geophysical Union meeting last week. All right, so you can avoid all this. Simply tap in. You understand? Simply tap in. All right, it's simply about tapping in. All right, simply. All right. All right, we're gonna get this. All right, gonna get this mem right here, man. Let's get it, man. We got more evidence, right? The water cycle describes the existence and movement of water on, in, and above the earth. What are we talking about? Hydraulics, right? Where does all the earth's water come from? Primordial earth was an incandescent globe made from magma, okay? But all magma contains water. Water set free by magma begins to cool down the Earth's atmosphere until it could stay on surface as groundwater, okay? Volume of Earth, okay? All right, let's go. Evidence. Global Resource Alliance. This organization, working with Hungarian water wizard Paul Payer, okay, has drilled over 80 boreholes to primary water at various depths in Tanzania, installing hand pumps that enable villagers to have easy access to clean water that is free of disease causing microbes, parasites, and surface contaminants. Before these wells delivered primary water to their village, women and girls were forced to walk miles in search of water, okay? In search of water on their heads. Sometimes women or girls were seized and killed by crocodiles at riverbanks as they filled containers with water, or they were attacked by rebels or bandits. Now there is safety and clean water for these villagers thanks to the work of GRA, okay? Since antiquity, the source of water generated deep within the earth, clearly defying the conventional scientific hydraulic cycle explanation, has been a mystery. How does one explain sources of water throughout the world that produce impressive quantities of fresh water, okay, often in dry areas with little rainfall or at high altitudes, okay? We're talking about Lake Superior. Besides numerous oases in the Sahara, okay, Arabic Peninsula, Middle East, and the driest deserts elsewhere, and countless springs at mountain tops worldwide, there are clear examples of this phenomena which stand out, like the Ain Fig Spring near Damascus, the Montezuma Well in Sonora Desert in Arizona, or the Zamzam Well in Mecca, okay? So research, check out that Montezuma Well, all right? It seems that ancient civilizations had a profound understanding of this phenomenon, all right? And moreover, a method of accurate locating of invisible underground water, okay, veins and streams without heavy drilling, excavating equipment. They have built impressive water supply systems all around the world more than 5,000 years ago. Ancient Persians developed the system of qanats, which eventually spread around the region and up to the North Africa. The water wells of Gibeon and Beersheba and huge cisterns of Masada in what is now Israel are a total puzzle to modern hydrologists, okay? So this is a puzzle to people that study the movement of water, all right? They cannot seem to understand that Ahau produces earth, and it comes from within the what? The magma, all right? For among rocks, there are some from which rivers gush forth. Others there are which then split asunder and forth water, okay? This is in the Quran, all right? Surah 2, verse 74, okay? We hear that the wars of the 21st century will be fought over water rather than oil, as in the last. Nothing holds more potential to abolish these wars and eliminate the shocking condition of nearly 1 billion people on Earth without access to clean, safe water, okay? Then the science of primary water, Paul Poyer, okay? Juvenile water, original water formed as a result of magmatic process. Juvenile water has never been in the atmosphere. magmatic water can form in very large quantities. Okay, magmatic water is juvenile water, is primary water. They had to give it another name. They didn't want to give this guy any credit. Think if you give him credit, you're saying that you've been giving us bad water for a long time, over 100 years. Okay, a magma body with a density of 2.5 and assumed water count of 5% by weight, a thickness of 1 kilometer and an area of 10 square kilometers, contains some 1.25 by 10 to the 9th power cubic meters of water. All right. Check it out. Tokyo Institute of Technology, okay? Associate Professor Motohiko Murakami was awarded the 2013 James B. Maselwine Medal at the fall meeting of the American Geophysical Union for his outstanding research on inner structure of Earth. Okay, Professor Murakami headed the team that made their calculations on the volume of water within the mantle based on their lab studies of the structure of the Earth. Secondary ion mass spectrometry measurements show that Earth's representative lower mantle minerals synthesized in a natural periodic composition can dissolve considerable amounts of hydrogen. Okay, all we're really talking about is their study, okay, and how this magma push forth water. Okay, inner Earth holds more water than the seas. All right, Professor Keith Harrow's Laboratory Department of Earth and Planetary Science Institute, okay, of Technology, Tokyo, specializes in high pressure mineral physics and petrology, okay, and led research group assisted by Associate Professor Murakami. Harrow's was originally interested in the generation of basaltic magmas and conducted experiments using piston cylinder apparatus on partial melting of periodics in the uppermost mantle. Okay, the above text provides a bit of contemporary research done to confirm the presence of water within Earth's mantle. Okay, so his research, okay, proved that inner Earth holds more water than the seas. Okay, all right, you got to overstand when somebody's telling you that we have more water under a mile than above, okay, than on top or sitting right on ground level. Okay, the water cycle describes the existence and the movement of water on, in, and above Earth. Where does all the water come from? Okay, primordial Earth was an incandescent globe made from magma. Okay, but all magma contains water. Understand that the water that we pool is going to come from magma. It has to come from the magma. It has to. It will come from the magma. Okay, all volcanic activity kept and still keeps introducing water in the atmosphere, thus increasing the surface and groundwater volume of the Earth. All right, straight up. No play. Water is consistently traded back and forth between the ocean and the rocky mantle because of plate tectonics, and research said super Earths are expected to have deep oceans that will overflow their basins, and inundate the entire surface. But we show this logic to be flawed, said Nicholas Kawan at Northwestern University in Illinois. Terrestrial planets have significant amounts of water in their interior. All right, y'all, that's the hijack. Superior Earths are likely to have shallow oceans to go along with their shallow ocean basins. Scientists suggest that technically, active super Earths store most of their water in the mantle, the rocky part that makes up most of the volume and the mass of the planet. Okay? Alright. Let's go. More evidence, right? Okay, so it is our goal to support the Hungarian water wizard Paul Pura, who is eager to work with us to pass along his knowledge and experience gained over 40 years of finding and accessing primary mem. Alright? In many parts of the world, Paul is a true heroic man, dedicated to end thirst through science of primary water. Alright? Well, let's understand one thing. Science has nothing to do with primary water. Alright? None. His mentor, Stephen Reese, spent decades himself in the quest of primary mem, and is an earlier pioneer in the field, as described in the book New Water for a Thirsty World by Michael Salzman in 1958. Israel Prime Minister David Ben-Gurion asked Stephen to find primary mem to supply a new city and port on Red Sea under construction in May 29, 1959. You can look that up. The Jerusalem Post announced that the Reese located wells were sufficient to supply a city of more than 100,000 people. More than 100,000 people. Enough to supply the city of Eilat and outlying villages. Alright? So, this is Stephen Reese finding wells, okay, not only in the land here of Tamari, right, but other places as well. Alright, so check it. Primary water wells are not a new phenomenon. Alright, well, you ain't even gotta use that word, because we don't, that phenomenon, nah. Anyway, primary water wells are nothing new. Alright, Stephen Reese was drilling wells all over Khalifa, okay, in the Middle East. As far back as the early 1930s. Alright, Paul has traveled to Africa numerous times, and earlier this year drilled 6 wells in Kenya, Tanzania, producing over 300,000 gallons per minute in an arrayed land. Alright, what's an arrayed land? With less than 10 inches of rainfall per year. Alright, so there's a land that is basically dry. Alright, pretty much groundwater has no effect here. Alright, according to Paul, it's hard to get the point across to many people in the U.S. because people been brainwashed, man, that the earth makes water. We can access it and solve our problems. We don't need massive storage facilities or aqueducts. Straight up, we wasting money. So I'm looking at water now like the whole NASA thing. Alright, understand how much money water brings in. Understand that Abba, the powwow, is having this being created for free for you. So far that we haven't even really tapped into it because it's bursting out in the ocean floors. Alright? It's busting out. The sea level's rising. Remember, climate change is a host. Straight up, no play. It's hard to get the point out to an American in the Marukan because of the necromancy, the spell. You understand me? There's no need for it. Think about it. Weather records usually are broken by only small percentage points. Not this time. Many old records fall by more than 40%. In the case of downtown Oakland, it was 58. The 1976 record being 10 inches of rainfall. In 2013 being 4.24 inches. Alright, link on that. Get you some wata, you know what I mean? Some wata. So, magmatic water or juvenile water is that exists within in equilibrium. Okay? An equilibrium is just a balance, a plateau state of mind for something, a liquid. Okay? A magma or water-rich evaluate fluids that are derived from a magma. Okay, talking about water. The water comes from this. Okay, this is the name that they're giving it now. Magmatic water or juvenile water. Okay, they're not gonna call it primary water. This magmatic water is released to the atmosphere during a volcanic eruption. Magmatic water may also be released in the hydrothermal fluids during the late stages of magmatic crystallization or solidification, okay, within the Earth's crust. Ultimate sources of this magmatic water include water and hydrous minerals, okay, rocks melted during subduction, okay, all things we covered, crystals, crystallization, crystallography, all right? So let's get it, man. Let's check this out. Do it all in real time, you know what I mean?
And then going to the industry.
Flag gazer, alright? Let's check it out. Let's get it.
The world is full of amazing places, both natural wonders and man-made marvels. But this place is different. This colorful...
Man, y'all see it, man. This primary rock. Alright? Primary rock, my nagas. Alright?
odd-shaped Dr. Seuss-esque waterspout is actually a little bit of both.
Primary water.
Hello, my name is Jared Ropalato and I'm a photographer from Vacaville, California. This is a photograph on a ranch called Fly Ranch. And when it started erupting water, that area flooded and became Fly. And when it was actually geyser,
is a bit repetitive.
It's called Fly Geyser because it was actually created on a ranch called Fly Ranch. And when it started erupting water, that area flooded and became Fly Reservoir. And now, sitting on top, is Fly Geyser.
And when Jared says created, he didn't mean by some earthquake or natural phenomenon. It was made by accident, when a power company drilled into a geothermic pocket in the 1960s and let loose a stream of boiling water, and with...
So, it was made by accident. Them boys dug in there, and what happened, man? Big old thing of primary water shot up, man. Shot up so much that rocks started popping out. Let's check it out.
With it, calcium deposits, which gave it that weird look over time.
Fly Geyser is always changing and always evolving. It's sort of a living sculpture. The bacteria and the minerals that are in the water create this colorful crust around it with terraced landscaping all around. And as more water shoots out, pieces break off and new pieces grow. So it looks different today than it did when I shot it.
And those vibrant colors are from something called thermophilic algae, microorganisms that thrive in hot water, like the boiling hot springs of Yellowstone.
The first time I saw it, I couldn't believe something like this could even exist. The vibrancy of the reds and the oranges and the yellows and the greens, it's just remarkable.
And Jared understands that it looks too weird for some people to even believe it's real. It actually has its own page on Snopes.com. But he also knows that within that doubt may lie motivation.
Some people might look at this photo and assume that it's fake somehow. If I hadn't seen it with my own eyes, I might think the same thing. I hope people that see this are sort of blown away by, not the photo, but by Fly Geyser itself. And I hope they're intrigued. I hope they're curious. I hope they wonder if it's real or if it's fake. And I hope that eats at them a little bit and they actually get out there and took a look at it for themselves. It's just one of those things. There's so much beauty in this world. There's so many crazy, crazy things like this. If you go out and you find them, go see this thing for yourself. You'll be blown away.
Primary rock, my knockers. Primary mem. You heard me? But check it though. This is what you buy at the grocery store. Let's get it. Crystal. Where does water come from, my knockers? Primary rock, crystal. Ain't no bullshit. You heard me? I'm not gonna lead you into some falsehood, you heard me? Crystal geyser. Alright, we just saw the video, man. We just saw the video, you heard me? Crystal geyser. Straight up. Where it's coming from. Is it coming from there, though? Is it? That's the question. Is this what you're paying for? Right? Alright, nonetheless, these are examples. Alright? These are examples. Let's get back to the Institute. Alright? Let's check it. Let's go. Question your land, my knockers. The powwow been had milk flowing for you for a long time. It just got incorporated. The necromancy, the spell. Still upon you, Yasharella. You got to wake up. Check it. Checking my knockers. How long it's been around? You ain't never heard been called primary milk. You ain't never been here called primary water, you heard me? There ain't such a thing. They had to change the name. Now we got magmented water or juvenile waters. Why is it called juvenile waters? Hey ya, hey ya, hey ya, hey, 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 hey ya, hey ya, hey ya, hey ya, hey ya, hey. Flowing milk, huh? They've been keeping it away from us. They've been keeping it away from us. Wake up, autochthonous one. Hey ya, hey ya, hey ya, hey ya, hey. Hey, A superior mem, buddy. I get it. It's in Peru, my knocks. The Peruvian waters. The Peruvian mem. This is in the desert, my knocks. In the desert, my knocks. Where's the water coming from? It's a well. It's natural. Straight up. Check it. Boy, swimming in there, man. It's a whole oasis. Primary mem. It's everywhere. Overstand everything. Overstand everything. Finna get this video, okay? They got an underwater river, alright? We're talking about primary mem here, okay? This comes strictly from the Institute of Primary Water, alright? So let's dig. Let's get it. I want y'all to overstand. I said 29 meters depth, alright? It's gonna trip your head out. She's gonna go under that. Feel me? And that's where you're gonna get this river of water. Feel me? Alright, check it. She in salt water now. What was at the top was fresh water. Alright, straight up. Let's get it. Let's get it before we dismount. Alright, lava. Hot, molten, or semi-fluid. Semi-fluid. What's the other fluid? Water. We pull water from what? From lava. Hot, molten, or somewhat water. Okay? Rock. Erupted from a volcano or fixture or solid rock. Okay? Resulting from cooling of this. Okay? Straight up. This is where the water comes from.
Lava.
Let's get it.
Magma.
Hot fluid or semi-fluid material below or within the Earth's crust, from which lava and other igneous rock is formed on cooling. Alright? So, igneous rock is what? We didn't cover this. Igneous rock is primary rock. Okay? Igneous rock is primary. Okay? Consisting of fire. Igneous particles emitted from burning. Okay? Containing fire. Having the nature of fire. Resembling fire as igneous in appearance. So igneous is what? Fire. Igneous rock. We're talking presta. Okay? A meteor thrown from the clouds. Okay? With such violence. Okay? Fire that is set on fire. We're talking igneous, we're talking presta, we're talking primary, first in order. Okay, who's a first in order? All right, first in dignity or importance, chief, principal, radical, original. We're talking autochthonous ones. We're talking OG, first. Adam, okay? The Great Plains, primary rock, igneous, okay? Igneous. Understand that there are abundance of things that was made for the autochthonous one, primary things, primary water, primary rock, primary air, and so forth. We're just talking first in order, okay? Understand and overstand that primary qualities of bodies are such as are original and inspirable by them, that they what? They duplicate. Everything's a phantom, everything's a duplication. We understand that from primary rock. From igneous rock, we have primary rock. We have gems, aka what? Crystals. Okay? All to come to understanding that all to come to an understanding that primary qualities of bodies, original bodies, are such original that they are inspirable. Alright? So we have crystals. Okay? We got Cristos, Jesucristos. Okay? The frequency, the power. Understand the intent. What frequency, what spell are you under? Alright? Primary rock. Okay? Primary tools, primary air, primary water, primary food. Okay? There's abundance of primary for the autochthonous ones. So understand and overstand that everything is a duplication. Understand that when we're dealing with primary mem, managa, that is health. That is the cleanest water you shall ever drink. And why are we not getting it? Why? Why are we being fed purified water? We don't want purified water. We want superior mem. Alright? So understand that the Christology is the structure of the atoms of the crystals. Okay, you find the structures in the mineralogy. The mineralogy is the breakdown of these crystals, of this primary rock. Understand what we're looking for. Understand we're looking for dikes, we're looking for cliffs, we're looking for them coming at a 90-degree angle. You want a strong movement under there. We're talking platonic plates that are moving from the volcanic pressure that's under Ahau. Understand that waters, mineral waters, are those waters that are so impregnated with crystals, with gems, with breakdowns. Okay? They call them foreign, but we already got perspective. Such as gaseous, sulfurous, and saline substance, as to give them medicinal managa. We're talking healing duels, or at least sensible properties. Alright? Most natural waters contain more or less of these foreign substances, but the proportion is generally too minute to affect the sense. Then why write it? Why speak of it? We're talking mineral waters. We're talking medicinal waters, sensible properties, revert. Okay? Are we speaking superior mem? Are we speaking the waters of the fountain, of the Presta? What are we speaking of? I just know that we need mem. We need clean mem. Shabbat Shalom to the home team, man. We'll go ahead and pump the brakes here, and we'll get back to this mem. You heard me? You tuned in, the water for tuning in. You heard me? Much appreciated. Much appreciated to all the comments left as well, too. You know what I'm saying? Heartbone every time, man. Ahau. For all my people that follow me, you heard me? The water for your vibrations.